Today we're going to talk section 6.1, which starts on page 398. And our topic today is integration or the antiderivative. Today we're going to talk about our basic integration rules. And this is called our power rule. Before we begin, I'm going to go ahead and review what it meant to take the derivative. So if I take f of x as our original function, and we set it equal to, say, 3x squared minus 5x plus 2, and I ask you to find the derivative. Well, to find the derivative, we had f prime of x equal to, we took the exponent, and we multiplied it to the coefficient, and we decreased the exponent by 1. So we ended up with 6x to the first. Derivative of negative 5x gave us negative 5, and the derivative of 2 gave us 0. What we're going to do in chapter 6 is undo that derivative. So we're going to give you the derivative, and we're going to ask you for the original function. The way we're going to set that up is with an elongated s, and then we're going to put our integrin, which is what our original derivative was, 6x minus 5, and then we're going to put a dx behind it. And dx is going to tell us the variable of integration. Our variable of integration will always be the same variable as what we're working with. Eventually, we're going to change variables, so we got to make sure that this variable is the same as this variable over here. Well, to integrate, we're going to undo what we did to find the derivative. So to undo, we're going to increase the exponent by 1 and then divide by that new exponent. So the integration of 6x to the first would be 6x to the second divided by 2 minus the integration of 5. We can write that 5 as 5x to the 0. Increasing the exponent by 1, we get 5x to the first divided by that new exponent, which is 1. Now this should bring up the question, well, how do we know what that 2, or what that number out there was? And at this point, we don't know. Eventually, we will be able to find it. So what we're going to do at this point is just to put a plus c. And that plus c is going to represent a constant. To clean this up then, we know that our original function was 6 divided by 2, which gives us 3x squared, minus cleaning up 5x to the first over 1 gives us 5x, plus our c. And we've got it almost back to the original function. The only thing we're missing is that constant that we had at the end, which now we're representing as a plus c. To go over our notation, we're going to say elongated s, which is our integration or our integral symbol, our function, or our derivative, if you wish, and then our variable of integration. We read this as the integration of x with respect to the variable of x. Our integrin is the function we're integrating, and the variable of integration is going to be on that dx. So I'd like to look at a couple of examples for integration, and we're just going to do some basic integration today. Nothing serious, nothing big, nothing crazy. The integration of 4x squared. We're going to take that 4x, we're going to increase the exponent by 1, which is going to give us 3, and we're going to divide by that new exponent, minus the integration of negative 5x, again that's to the first, we have 5x to the second divided by 2, plus 3, we can write as 3x to the 0, so we can write as 3x to the first over 1 plus c, and that's our original function, f of x. We can clean this up just a little bit. So we have 4/3 x to the third. We can take that x to the third, remember, and put it in with a numerator, or we can take it out to the side, either way, minus 5/2 x squared, plus 3x plus c. Some of you will be able to take that 3x to the 0 and simply go to 3x and skip this middle step. Others, go ahead and write it out. Now it does become a little more complicated as we take the integration with the variable in the denominator. Well, this is simply simplified by taking that denominator and bringing it to the numerator. So the integration of 1 over 4x to the third dx can be rewritten as the integration of x to the negative third over 4 dx. Notice I left the 4 in the denominator. I really don't want to move that up because that makes it a negative exponent, and we're not really interested in that number to start with. We could really also write this as 1/4 the integration of x to the negative third dx, because we could separate this original integration or integrin to 1/4 times 1 over x to the third dx. And we're going to see that that coefficient can come to the outside of our integration symbol. Now if I look at the integration, I'm going to increase the exponent by 1. If I increase x to the negative third, or negative 3, by 1, I get x to the negative second over negative 2 plus c. And that's going to be my original function. I can clean this up because you know I don't like negative exponents, as taking this x to the negative second back to the bottom. We can also multiply our 4 and our negative 2, so we get negative 1 over 8x to the second plus c. And that's going to be our final answer for this point in time. In example 4, we get into some radicals. Well, we can change a radical into a fractional exponent. So the square root of x is x to the 1/2. The cubed root of x squared can be rewritten as x to the 2/3. And that's going to be dx as being our variable of integration. Variables with fractional exponents are going to work exactly the same way. We're going to increase that exponent by 1. So x to the 1/2 increased by 1 gives us x to the 3/2 divided by 3/2 plus x to the 2/3. If I increase that exponent by 1, 2/3 plus 1 gives me 5/3. Remember, 1 is 3/3. 2/3 plus 3/3 gives us 5/3. So we have x to the 5/3 over 5/3. Now we're not going to forget that plus c. Very vital that we have that there at this point in time. We can go ahead and clean up this new function. If we divide by a fraction, we can simply multiply by the reciprocal, and we end up with 2/3 x to the 3/2 plus, if I take 5/3, multiply by the reciprocal, I get 3/5 x to the 5/3 plus c. And that's going to be my original function. Lastly, if I integrate one more fractional exponent, x to the 2/3, I can integrate that. Adding 1 to 2/3, I end up with 5/3 divided by 5/3 plus c. Flipping that around, multiplying by the reciprocal, my original function, f of x, is going to equal 3/5 x to the 5/3 plus c. And that's going to end where I want to get to today, which is just our basic integration rules.